Hello, welcome to another edition of the CNA's Opus. My name is Rich. I'm a certified nursing assistant. What I want to talk about today is I just want to touch on the PI3 mTOR pathway, and it's some of the older work that I studied throughout the summer. So like, I don't really like to rehash some of the work that I did over the summer, but I think it's important for me to reiterate it, and it's something that I'm more comfortable with because I've impounded it. It was ingrained in my head I worked with a doctor named Dr. Bill, and he's taught me this stuff, and this was ingrained into my head. So I'm going to do the best I can to articulate it to you. Even though I'm not very good at speaking, I'm going to do the best I can to articulate it to you. And I'm just starting off with it. I'm not going to go through the whole thing because I don't have my magic markers. My Martha Stewart board, it broke. You know, it's $5. You get what you pay for. So anyway, first thing is first. Is a phospholipid bilayer, and what exactly is a phospholipid bilayer? Like, what is your cell membrane? So your cell membrane consists of, if you can look at my notebook right here, and if I'm able to point to it, right here you're gonna have a glycerol right here on the inner leaflet of. So this would be the intercellular, the inside of the cell, and right there is glycerol. And off the glycerol, off the first hydroxyl of the glycerol molecule is going to be a fatty acid or our carboxylic acid chain. And then off the second glycerol hydroxyl group is going to be another fatty acid. Then off the third hydroxyl group of the glycerol molecule is going to be a phosphate group. And if you don't know what a phosphate group is, you can go to my previous videos, or well, whatever. But anyway, so off the glycerol molecule on the inner leaflet here of the cell membrane, you're going to have, going inwards, you're going to have this hydrophobic carboxylic acid chain, or a fatty acid, attached to an alcohol group off the glycerol, the first. Then the second hydroxyl group has another fatty acid going in, and these are hydrophobic here. That's why the alpha helix works so well with the inner core of the phospholipid bilayer, because they're both hydrophobic, so they both work together, they both cooperate with one another, because the alpha helix, which you'll see in the 7-membrane alpha helix of G protein coupled receptors and receptor tyrosine kinase, is that they're both hydrophobic, so they work together, they're not working against one another. And off the third hydroxyl group here is a phosphate group. So if we go down a little bit, this is I hate mispronouncing this, phosphatidyl inositol 4,5 biphosphate. And what that is this is the inositol ring right here. So right here, the inositol ring by itself is a 6-ring carbon. It's like a benzene ring, but off of it, it's going to have off of each carbon, it's going to have an alcohol group and a hydrogen. So each carbon has its 4 bonds going here. Right down here is, this would be phosphatidyl inositol 4,5 biphosphate. So that means this is going to have 2 phosphate groups put onto the 4th and the 5th carbon. This is the 4th and the 5th carbon, not this. If you took this off right here and put the phosphate group onto here, That's myo-inositol. That is not the same thing. That is not the same thing, and it won't work. It won't work the same way. So this is phosphatidyl'inositol 4,5 biphosphate, and that's the 4th carbon, and that's the 5th carbon with the phosphate groups coming off of it, and it's often abbreviated to PIP2, which isn't like an accurate abbreviation if you're a chemist, but it's the one that's used. So anyway, that is what's most that is commonly found in the cell membrane. So going on from there, I hope you got that right there about a phospholipid bilayer and the inositol ring and phosphatidyl'inositol 4,5 biphosphate. So then now things like receptor tyrosine kinase or RAC1 or RAS, G monomeric proteins, they can convert phosphatidyl'inositol 4,5 biphosphate into phosphatidyl'inositol 3,4,5 triphosphate. So now you have 3 phosphate groups. And in order for PI3-AKT mTOR pathway to work, you need 2 of the phosphatidyl'inositol 3,4,5 triphosphates in the cell membrane at the same time. And these are transient signals. If you can read that, these are transient signals. And you need 2 of them to activate the PI3-AKT mTOR pathway, because it's needed to recruit 3 serine threonine kinases. One is phosphoinositol dependent kinase 1, and the other is AKT, also known as protein kinase B. Now, phosphoinositol dependent kinase 1 is activated as soon as it gets to the cell membrane, and there's phosphoinositol 3,4,5 triphosphate there. It becomes activated. When it recruits out of the cytoplasm protein kinase B or AKT, that doesn't immediately activate it. This here, if you can see my silly little diagram down here, this is phosphoinositide dependent kinase 1. As soon as that hits the cell membrane right here with this I'm just going to call it PIP3 because I have trouble pronouncing that word. This serine threonine kinase becomes activated. That's all it needs. That's simply all it needs. This one over here, protein kinase B or AKT, when it's recruited from the cytoplasm of the cell, it doesn't become activated immediately. It has to be phosphorylated onto a serine or threonine over here from phosphoinositide dependent kinase 1. So this will come up, this will become active, and it will phosphorylate its neighbor. It's like its buddy. It has to phosphorylate it over here. But you notice 2 of them have to be into its PIP3 form at the same time. So it has to recruit 2 proteins. And then this one becomes activated. This is phosphoinositol dependent kinase 1. That becomes activated as soon as it hits the cell membrane. And that's a serine threonine kinase, which means it's going to add a phosphate group onto either a serine or threonine kinase residue on the other protein here, on the other serine threonine kinase. This is another serine threonine kinase. So that adds a phosphate group onto protein kinase B, which is commonly what's used now in the literature, they use protein kinase B instead of AKT. Even though AKT is in the name, PI3-AKT mTOR pathway, they use protein kinase B. So that gets phosphorylated by this over here, by its buddy. And then the mammalian target of rapamycin complex 2, which is also a serine threonine kinase, comes in and phosphorylates protein kinase B, or AKT. That's when it becomes active. And when it becomes active, it drops down into the cytoplasm of the cell, and it inhibits something called the tuberous sclerosis complex, which I'm going to get to possibly in a different video, because that's a whole, with Reb and everything like that, that's a whole different story altogether. But just to start, I hope you gained something out of this, and Rich, CNA. See you later. I stopped this fucking thing.